morning. We are going to be talking, hopefully for about the next hour, about GIS, or Geographic Information Systems, and how they can be used for demographic analysis, demographic reporting, how you can integrate enrollment forecasts, and generally how it assists and helps districts with very important planning issues. Before we get started this morning, we're going to show a few slides, and then we'll get into some live demonstrations. Regarding the slides, for those who have never used GoToWebinar before, a couple of important issues, little housekeeping chores here. You have a panel that should be on the side of your screen. On that panel there is an orange button with an arrow on it, and that will allow you to dock your little control panel out to the side, sort of hide it if you will. You can undock it as well. You have a panel where you have my screen being shown, and you can of course resize that to make it as large as you want on your screen. But more importantly, there's a section in the control panel about questions. So at any point during our presentation here this morning, if you'd like to type in some questions and then click the send button right down below, towards the end of the presentation we'll have some time hopefully to answer as many questions as we can. So feel free to answer or ask questions, and we'll take care of those towards the end of our presentation. So let's go ahead and get into our presentation. Just a little bit of information about who we are, who I am. I'm president of Davis Demographics and Planning. We're a company that focuses exclusively on using GIS, or Geographic Information System tools, to assist school districts in planning. About 70% of our business, our work, is actually using our own tools to provide consulting services to school districts. But we do license these tools to districts that want to bring this kind of technology, this kind of ability in-house to continue their planning processes. We've been doing this for about 26 years, since the mid-'80s. We have about 180 school district clients throughout the U.S. Most of them outside of California, where we're located, are software clients. So they have licensed our tools and we support them, and they are self-sufficient in their planning tasks using these types of tools and technology. We teamed up with a company called Esri, or Esri. They are the 800-pound gorilla, like I like to affectionately call them, in the GIS field. About 85% of all the cities and counties throughout the United States use Esri mapping technology, which means that school districts can take advantage of the wealth of data and everything that's out there. I always tell school districts, well, they ask, where do we get started with this? How do we get street data and other kinds of data to get us going? The very first step is to check locally with your county to find out what GIS, or if they're using GIS, what GIS they're using, and it opens up all kinds of interesting discussions about data and what's available. For our work with the Esri and the technology, and what I'm about ready to show you here in our demonstration, we have been twice voted their Business Partner of the Year, most recently in 2010. The next slide here shows where our clients are located. As you can see, they're scattered all over the country in about 28 different states. Basically, Texas and the Southeast are heavily high growth areas for us. A lot of growth in those areas. Economy's good, and districts are finding these tools, making them even more efficient. Some of the things that we can do with GIS. These are just some example slides and maps, screen captures and maps, if you will, of some of the projects that we have worked on. Certainly there's a wide range of types of projects that other districts have done as well. I'll just talk about a few of those after I go through these slides. But this is the Etiwanda School District. It's a fairly medium-sized school district with about 12,000 students. High growth area. A number of years ago, they asked us to help them, assist them with looking for new school sites and so forth. And the brown areas that you see over here on the left are new subdivisions mapped. The red areas are planning areas that the district has been divided into, and we do enrollment forecasts with the GIS software to generate forecasts and allow us to manipulate these planning areas to carve out potentially where new schools should be located, generate theoretical attendance boundaries to accommodate growth in different areas, and so forth. This is a project that we've worked on with this district before and is ongoing as well. Along the same line, this is the Desert Sands Unified School District. We've worked with them for, probably about 15, 16 years now. And in fact, this is a 1996 old-style map, if you will, using GIS, where we master planned high school sites. And back in the mid-90s, we identified a fourth high school, generally up in this area that I'm sort of highlighting here. And it sort of went against the thought process at the time, but as things have developed and evolved, that's indeed exactly where the school site was needed. And we assisted the district using these tools with their committees in the community in developing the boundaries for the opening of their next high school, which is the Shadow Hills High School, which opened about 2 years ago, 2 or 3 years ago. Also, Pasadena Unified School District, well known for the Rose Bowl and Rose Parade. This is a district that had changing demographics over time. They had desegregation orders in place for about 30-some years ago. The district had changed demographically. It was more homogeneous, and some of the issues weren't in play anymore. They were also in decline in certain areas, and so they closed 2 schools a number of years ago, took the opportunity during those school closures to look at the complete reboundary of their elementary schools, getting rid of non-contiguous attendance boundaries, inefficient boundaries, and ended up in the process saving about $1 million a year in transportation after redesigning and making more efficient boundaries. So GIS can have a big impact in a number of ways, not just in boundaries, but consequently in the resulting transportation issues that come into play. Also closing sites for another district here. The map on the left shows walking distance polygons, the red outline. This is basically a district who expanded an existing site on the periphery of town while closing a school in the center part of town where there was no growth. And so we looked at a number of issues, not only where children who were taking advantage of certain programs were located, how could they be accommodated, but also was it possible for the kids in the closed school site area to easily get to other schools, and how far would they have to walk. These were all kinds of different kinds of things that were necessary during the analysis that GIS certainly helped with. So those are just some examples. Again, it doesn't have to be boundaries. It doesn't have to be forecasting. It doesn't have to be some of the typical things you think about. GIS is a very flexible and very powerful tool. We have some districts that have actually mapped child obesity and looked at fast food restaurants and tried to see what the correlation there was and how to deal with that. I mean, there's just a whole variety of different types of things that can be done. We have districts that are mapping their facilities, bringing in CAD drawings as well, and building a facility inventory of all their facilities and bringing CAD into GIS and using that for mapping and analysis. So there's just a wide variety of ways that you can use these tools. We have built all our tools on top of ESRI's software platform, and we have a couple of products or services, if you will. The one that we're really going to concentrate on here this morning is SchoolSite for ArcGIS Desktop, which is the screen you see in the upper left-hand corner. This is a set of extensions that work within ESRI's ArcView, ArcEditor, and ArcInfo software. The extensions do redistricting and demographic reporting, as well as integrating redistricting efforts with integrated enrollment forecasting model. We also have some web-based tools as well. Some of you may have seen some of these before. It's really a growing thing. SchoolSite Locator on the right is a web service, which means we provide a URL to the district to place on their website, and when somebody clicks on that URL, it brings up a web map in their browser of the district and allows parents and staff to find addresses, find schools of assignment, get driving directions to schools, find out what trustee areas you live within, click on a link to go to the school's webpage. It's basically a nice front end for parents and staff to get information about the district. And there's no software required. It's just a link that we provide, all hosted on our servers, and is a real time saver and therefore money saver for district staff. We also have for smaller districts SchoolSite Online down at the bottom, which is sort of a mini version of some of the desktop tools, demographic reporting, mapping, and some simple redistricting as well. And this is aimed for districts roughly of 10,000 students or less. But these are all the kinds of products and services, and like I said, we're going to spend time here this morning on our demonstration right now with SchoolSite Desktop for ArcGIS from Esri. So let me just switch over here, and I'll minimize that. And what you see here on the screen basically is one of Esri's software products. This is ArcEditor. Some of you may have heard of ArcView before. That's also widely known. Our software works in all of these technologies from Esri. And we have an aerial photograph on the screen. The black outline is the district boundary. Over to the left here, we have what we call the table of contents. And this is a listing, if you will, of all the map layers that we can turn off and on if we would like on the screen. Okay. These layers can be customized, obviously, depending on what data you have. Student data, street data, seismic zones, floodplains, there's just a variety of types of data out there. You can add these data layers to your map, customize them, query them, and so forth. I've actually added or clicked on and shown another layer here, which is our high school student points. They happen to be color-coded by their actual school of attendance. So you can see just by the colors here, in essence, sort of where the boundaries are for the schools. But at the same time, you can also see some mixtures of different colors of students, and these are students that are transferring or doing interdistrict transfers within the district. Again, the power of GIS, among many things, is the power to visualize the data and understand your data better than just looking at it on a spreadsheet or a set of numbers. Okay? So again, I think this particular map provides some powerful information to a school board about how open enrollment policies might be affecting the district, and we'll talk more about that as we go through the demo. Everything about these data layers means that all these layers include information behind them. It's not just a pretty map, but each layer has a database behind it. That's what GIS is all about. I've turned off the aerial photograph and turned on my streets here in this example. And I can actually zoom into a specific area. And when I zoom into an area, I can actually turn on the street names if I'd like. So we'll pop our street names on there, and the street names came from an actual database of information about the streets. So I can open the attribute table here. Let me get a little larger here so you can see it. And we have the name of the street. We have information out to the right as well as address ranges, left side and right side address ranges. Okay. So there's data behind each street block. There's a record, if you will, for each block in the database. And that applies to every layer. Every layer has data behind it. Okay. The data behind each layer sort of describes what the features are in that layer. Obviously, if we have water mains, we have pipe type, we have pipe diameter, and so forth. Our streets, we have names, address ranges, maybe speed limits, type of pavement, number of lanes, whatever. We get into parks, waterways, of course our student data that I showed you just a few seconds ago. I'll pop the students up on the screen. The student data has information about the students, and that typically comes out of your student information system. Okay? A process called geocoding in the software will take a list of students with their addresses out of your student information system and map those students along the streets based upon the address ranges in the streets database. Okay? If I were to identify or click on a particular street, let's go ahead and click on a particular street here. I'll do that one more time. Click on that street. We'll highlight it, sort of flash it so you can see the one I'm looking at. Okay. And again, I clicked on that street and identified Lindenholt Street and the address ranges and other information about that street. So again, every layer here has information about it. I can go in here and add new data if I want. And let's go up a level and let's find my student data. And we'll go in here and add our students again, for example. We're going to add our students to our map. Here's our students that have been added to the map. And I might want to query these students now from some information on the student database. For example, I can build a query that says I want to show only kindergarten students, or grade equals 0 in this case. So I'll go in here and double click on the grade field, click on equals, and then type in 0 and click OK. And then once I go in and apply this, you'll notice that the density of these dots becomes less because I've filtered out, if you will, and are showing only kindergarten students. And I can name these K students and click on OK. So here's our kindergarten students. Okay. Let me back out again and look at it overall. Here's all of our kindergarten students in the district. I might also go in here with some element in the student database and say, show me all these students, these kindergarten students, but let's color code them by ethnicity, for example. So I'll come in the properties for this layer, go to symbology, click on categories, click on unique values, and choose the ethnic field out of my student data. And the student data here is using numeric values for their ethnic field. I'll make them a little bit larger so you can see the colors here. And I'll click on OK, and now I'm color coding my ethnic students, or excuse me, my kindergarten students by ethnicity. And you begin to see patterns and so forth in the particular area. I can actually go in here and select some of these students as well. So I might come in here and let's just make sure my kindergarten students are selectable. That's good. And I'm going to use one of my tools to select these students. I'm going to use the Select by Lasso tool. And I'm just going to grab the kids in this particular area right here. Those students are now selected. There's 74 kindergarten students. And I'm going to go ahead and open the attribute table. And you can see some of them that are selected. I'll show all the selected 74. Here are the selected 74 students highlighted in light blue as they are on the map. Okay? And of course we can take this data and summarize it a variety of other ways as well as exporting it into other file formats. Maybe you might want to contact people in a particular area and do a mail merge or something like that, send letters out to parents of these students. Okay? Very, very simple to use Windows-based kinds of tools. Let's go ahead and clear those students. So we're putting them back the way they were color-wise. Okay? And we'll zoom back out district-wide. Okay, I'm about ready to get into redistricting here, sort of moving beyond some of the ArcGIS, ArcView types of tasks. Obviously, we have a lot of other data we could show here. We could show water features, different layers. We could show parks, if you will, different layers. We have our aerial photography. We can stream in other types of maps and so forth from other users out in the ESRI community over the internet in here. We might go out and search for seismic zone maps. Other users may have created those, and we can grab those over the internet and bring those into our mapping view here if we want. There's just a variety of data out there that we can use. We've actually done some additional analysis in the software to show us the density of where students are, sort of a heat map, if you will. And if we have multiple years of student data where we can create these density maps, we can actually combine them together in the GIS to see where we're losing kids from neighborhoods or where we're gaining kids over time. Again, a tool to help people understand the impact of changing demographics of the district. One of the key things that we deal with in terms of layers of information, in terms of redistricting, is very similar to what the Census Bureau does. They have census blocks, block groups, census tracts moving sort of up the chain, if you will. When we do planning for school districts, we break the district into study areas. And you should see on your screen now light blue outlines. These are study areas designed for this particular school district. You'll notice each study area has a number inside as well. Each study area is assigned a unique ID number that identifies that particular planning area. Some districts call them grids. We call them study areas. You can call them anything you want. But the idea behind study areas is these are the building blocks for any kind of redistricting efforts involved in using the software. Okay. We also use these study areas as the smallest geographic area for which we can generate enrollment forecasts. Now, anyone can do enrollment forecasts by school attendance area, but when you have numbers at that higher level, it does not give you the detail you need to come up with alternatives for growing areas. For example, if I have an elementary school that shows my enrollment going from 500 to say 750 or 800 kids in the next couple of years, that's nice to know, but how do I actually solve the problem there with that over-enrollment? I need to be able to carve out or break out portions of that enrollment or future enrollment to perhaps move to neighboring schools, or perhaps group together these planning areas in the potential attendance area of opening a new school. And so these are very important concepts to any kind of redistricting software, not just what we do, but any redistricting software out there. Again, these study areas have attributes. So if I were to click on a particular study area, for example, let's highlight one. I'll click on study area 80 here. You will find that I have, for that particular study area, it's assigned to elementary school 261, middle school or intermediate school 380, high school 394, and we also have other information about the study areas. This particular study area is assigned to trustee area 4. This district has school board members elected from certain trustee areas. So just like our students, that we could color code by ethnicity or query and show only 9th through 12th grade students, we could actually color code our study areas to show our attendance areas, because those school codes are in the attributes for our study areas, and we can use the software to color code based upon those different fields or attributes. Here we're showing our high school attendance areas based upon the color coding of our study areas. Okay, so the idea is we can, when we do redistricting, we can actually click on a number of study areas and temporarily reassign them to other schools. The map will refresh with colors and also recalculate the numbers for us. So let's actually do that. I'm going to turn off my study areas, and I'm going to go up to our redistricting toolbar, and I'm going to open up a redistricting plan that I had previously saved. And let's go find that. And we'll look inside our database here, and I have a plan here called High Plan A, and I will click OK. And High Plan A will be added to my map. You see color-coded, and with the comprehensive high schools located on the map, the 4 high schools in this particular school district. The black outlines, again, are our study areas. And like I said, they are color-coded by the current school, high school attendance boundaries. Now, I have all the functionality of ESRI software still available to me. This is like an add-in, a plug-in. This is our SchoolSite software working within ESRI software. I can go in here and take our streets and drag them up to the top here. And that'll refresh or change the drawing order, if you will. But for now, I'm going to turn off our streets and make a very simple map. And in our toolbar here, up at the top in our redistricting toolbar, I'm going to show the statistics window now near the bottom. Let's move our map up just a little bit here on the screen. And in our statistics window for this particular plan that I've created, it's showing me the numbers of students. This is high school. It's showing the number of 912 students residing in each area. And these are current students in this particular plan. I can also do plans based upon forecasted or future enrollment numbers. I'll show you that in just a bit. But we have 1,829 9th through 12th graders living in the Canyon High School area up here in red. We have 1,593 in El Medina's area in green, 2,357 in Orange High School, and so forth. I'm also going to come up here and turn our capacities on for our schools so we can see how balanced that is. And we certainly have some problems here. El Medina can take 2,250 kids, yet it only has about 1,600 students residing in the area, whereas we have the exact opposite with Orange High School, about 1,950 capacity with almost 2,400 students residing in the area. So we're going to do a very simple boundary change. We're going to come up here and we're going to start assigning. We are going to move some of the planning areas or study areas from Orange High School over to El Medina. So El Medina is going to be our target school. And we're going to use one of our drop-down tools to select some study areas. We'll do the Select by Lasso tool. And we'll just sort of drag a graphic around here and select a half dozen or so study areas. Those particular study areas have 337 high school students residing in that area. If I were to move those half dozen or so study areas from Orange to El Medina, my proposed statistics tab shows me that El Medina would jump up to 1,930 and Orange High School would drop down to 2020. Certainly an improvement, not necessarily where we want to be, but let's go ahead and make that assignment. So we'll right-click, Assign Selected, and those areas will now change color over to El Medina, and our proposed statistics and current statistics have now been updated. Now this is a copy of our data, so we're not hurting any of our core information. We're playing what-ifs with this particular plan, and we can have a number of different scenarios that we can be working on. We can actually have an active plan up here, maybe multiple plans open at once in our document here, and flip back and forth between these plans. Maybe we have a plan for elementary where we're looking at making some changes, and then we can switch to our active plan, which might be a middle school plan, and we can affect the same boundary changes to try to keep feeder patterns consistent. So we can have multiple plans open at the same time and allow us to work back and forth with different plans. Okay, this is a copy of our data, and I'm playing what-ifs. None of these take effect until I actually save this plan. So up until the time I save, I can actually do an undo if I want. Even though I had an opportunity to take a look at what I was doing, if I decided I didn't really want to do that after all, I can click undo. I can do undo multiple times up to the last time I saved my work. Okay. I have the capability, let me stop my assignment here. I have the capability to actually look at different grade configurations as well. So right now I'm looking at grade 9-12 down here, but maybe I might want to look at grade 10-12. Click OK. And down on the bottom I get another column showing 10th through 12th graders as well. This can be useful, maybe not so much in the high school example here, but if I'm working with elementary schools, many times districts will say, well, you know, we're looking at bringing 6th graders back from the middle school in the elementary schools, or perhaps vice versa. You know, what would be the impact of that? Well, we can model that very quickly by looking at different grade configurations for these school attendance areas. Okay. Another example would be what would happen if I bumped up to K-8, for example. What would that do to our existing schools, and how might I change the boundaries to better balance those schools with kindergarten through 8th grade? Okay, so we can look at a variety of different grade configurations. This is also helpful too if you're opening a new high school. Typically, you might open it with 9th and 12th, or 9th and 10th graders, and then bring those over a 2 or 3 year period to a full 9th through 12th grade school. Okay. So again, grade configurations can be looked at. We can also look at other student attributes besides just grade level. Any attribute that's in the student database can be reported on and queried. Again, ethnicity is a typical example, but this drop-down list is created on the fly depending upon what student data I use in this setting up this plan. If I dump a whole bunch of information out of my student information system, I could have a very long list of fields here that I can report on as I do my work. Okay, so an example here of ethnicity. I'll click OK, and in this particular set of boundaries as they currently exist in this plan, I'll get a breakdown by ethnicity, and you should see that down at the bottom of the screen. You'll notice at the top here 1 through 7. These are the values that the software found in the ethnic field for my student data. Your data might be letters, it might be spelled out. Software really doesn't care. We're just saying, look in this field, tell me what values you find, and tell me how many records are there in each of these attendance boundaries. So if I modify these boundaries, these numbers, of course, will change. And we're using ethnic codes 1 through 7 in this example. I have 494 students, 912 students out of the 1,593 in El Medina's attendance area that are of ethnic code 1, 862 are of ethnic code 2, so forth and so on. Now, I also might not want to look at it in terms of raw counts. I can also display those as percentages. So many times when you're balancing enrollment, you want to look at percentages among schools, not necessarily the raw numbers. So this will display that down in the window down below. 0.31, or 31% of the kids are of ethnic code 1. 0.54 are of ethnic code 2, 54%. 0.02, 2% are of ethnic code 3, so forth and so on. We actually have a total line down here as well, so you can see for 912 what the district average is percentage-wise in each of these ethnic categories. Okay? And again, those percentages will change as I adjust boundaries. Let's turn off display percentages. We'll click on show grades. Showing grades will drill down and not only tell you not only 9th, 12th, but it'll give you individual grade counts. So grade 9 for Orange Canyon High School, 472 students. Here's the ethnic breakdown for those 9th graders. 10th grade, 480 students. Here's the ethnic breakdown for those students. And at any point, if I want to print those out, I can go to my plan report, where I get a list of what's basically showing down the statistics window, and I can print this out. I can export it to a variety of formats, including Microsoft Excel. So I might want to take these stats and manipulate them further or put them in other reports or whatever, so I can export those into a variety of formats. Okay? I can actually look at opening new schools, but I'm not going to do that with just this particular not with this particular plan. I'm actually going to bring in enrollment forecasts as well. I have done an enrollment forecast in our software, and I am going to browse for an enrollment forecast. And I've got an enrollment forecast that I've previously created called Projection 1, primarily because I'm not real creative when I name things. But anyway, we've got Projection 1 up on the screen here now. And I'm going to open up the projection properties. And as I mentioned, projections are developed by planning area. So as you saw when I did a little redistricting here a little while ago, I'm actually manipulating these boundaries by interactively selecting a number of study areas, and it recalculates the numbers as I move them from school to school. Okay? If I have not just current students for my study area, but I actually have enrollment forecasts for each study area, then I can set up boundary plans using or attached to these forecasts and look out in the future as I adjust boundaries, perhaps with the idea in mind of opening a school or perhaps closing schools and so forth, which I'll show you here in just a second after I chat about enrollment forecasts. So we have enrollment forecasts by planning area. I had gone through a wizard to get to this point to set up this enrollment forecast, and I've entered in some additional data about the forecast as well. And I can actually display my forecast by planning area, by existing attendance area, various district summaries, and so forth. I'm going to actually show study area. We'll just show study area 7. This enrollment forecast model goes out up to 10 years, year by year, up to 10 years. And we also have an optional maturation or build-out forecast for districts that have large areas of undeveloped property that could develop in the future. Maturation or build-out forecasts are good for long-term siting of new schools, helping the district decide the most efficient area, the most likely area to open up future schools. But our typical enrollment forecast is up to 10 years. Build-out is an optional forecast. So I'm going to show my projection for study area number 7. I'm going to look at the first 7 years of my enrollment forecast, and I'm going to summarize my enrollment forecast by K6, 7, 8, and 9, 12. Click on View. And here is my enrollment forecast for that particular study area. Now this is older data that I use in my demos. We're not actually back a decade ago, but this district was nice enough to allow me to use their data for demonstration purposes, so it's a little bit older data, but hopefully you'll get the idea here. This is study area 7. We have our existing students, actual students at that point in time. These are geocoded students residing in that particular study area. These kids matriculate through the grades each year, and these numbers are modified by a number of factors, including birth data, which will affect our kindergarten class, as well as mobility factors, which are similar to cohorts, not quite the same thing, but they're in essence grade progression ratios based upon historical enrollment by study area, as well as projected housing units, different types of housing units generating different numbers of students. We have student yield factors to go with our housing units and so forth. So there's about 4 or 5 factors that go into these individual projections by study areas. Number 1 is their growth in that area in terms of births in the general area. What has been the history in those particular study areas of kids moving in and out of existing homes, dropouts, and so forth, as well as is there any potential future development that's being planned in that particular study area? What are the yield factors to be applied to that potential new housing, and therefore we're getting some additional kids in this area as well. So all of those factors adjust these kids as they grow through the grades. We have shown K6, 7, 8, and 9, 12 down here at the bottom. We can actually show 6, 8 as well. We can do different grade configurations. We'll do K-12 total. Click on View, and we also have now our 6, 8 and our K-12 numbers as well summarized. Okay, so we can look at any study area we want and look at the projections for those particular areas. All of these variables that I just chatted about, if you go in there and modify those, the software will automatically recalculate the projections and give you a new set of numbers. It's almost like auto recalc on an Excel spreadsheet. Okay? Now we can also, because we've done these by study area, we can also summarize these up into existing attendance areas. So I'm going to show an elementary area. I'll pick Canyon Rim Elementary from my drop-down list. Since it's an elementary, I will just show K through 6, click on View, and this is the Canyon Rim Elementary projected resident enrollment in those areas. Okay. Now this is resident enrollment. It's not actual enrollment. This is GIS. We're talking about where kids live. We're talking about boundary and location issues. We're talking about where we want to open up schools based upon where students are residing, or where schools might want to be closed based upon where students are residing. This is not, it's not a tool to try to figure out how many teachers are going to be at a site based upon where students may feel they want to go. Okay, this is residence. This is true planning in the district, long-range planning. So this is the resident enrollment in the Canyon Rim Elementary attendance area. What this in essence is a summary of all the individual study area projections that make up Canyon Rim. So if I were to go back and modify some variables in 2 or 3 or maybe even just one study area in that area, those study area projections will update, as well as the individual school projection. It's the bottom-up approach to forecasting. What is actually in that area? What's the impact in that area? Okay. I can also go and look, for example, let's look at our high schools. Well, I'm going to pick El Medina High School, and I'm going to show 9th through 12th grade. So here's El Medina, 9th through 12th grade. 1,593 students. We saw that, I think, a little earlier in our redistricting. That's how many students, 9th through 12th grade students, reside in the area. And those kids come on down through the grades, and you'll notice that we're growing up to mid-2000, 2,600, 2,700 students on further out into the future. Why? Because, well, we have a pretty good number of kids coming up through the grades. Here are the actual students from the lower grades coming up through the study areas that make up El Medina High School. And we have a bubble coming through, We also have a lot of development that's going on. One of the things I didn't mention or show is development. We can actually, in our GIS, actually map where these projects are. And if I identified a particular project, let's choose a tract, for example. Let's move down and find that. And click on a particular tract. We have information in the database about the application number, the study area it falls within, the project name, St. Anne Place, the developer or applicant, Centex Homes, 125 single-family detached units, and a construction schedule as well in the database for that particular project. That information gets automatically built into our enrollment forecasting process, and those numbers will get added into our modeling of our forecasts. And here's our projected housing units, and we can actually go in and modify these numbers after they've been entered. And obviously it can affect our projections. Maybe we might say, well, that developer's a little bit aggressive. Let's move the numbers further out. Let's see what that does to our enrollment forecast. So the concept here is we have the ability to do enrollment forecasts for these planning areas and then plan with that information using our redistricting tools. Just a few more items before I get out of forecasting. Again, GIS is all about visualization, so I might want to color code enrollment change based on my enrollment forecast from, say, 2001 to 2008, and I will show my enrollment change maybe for high school, 9-12. I'll click on OK, and it will now color code my map to show me hotspots based upon enrollment change between those two pair of years. The reddish or orangish areas are areas of increase, highly increased numbers of 9-12 students. The green areas are areas where there's actually some decline between that time frame. So we can actually see our numbers on the screen as well as color coding to show where our growth or decline is projected to be within the district. So we have all that capability available. Let me clear that back. And let's go back to redistricting for a minute and bring these two things together. So what I'm going to do here is I'm going to create a brand new redistricting plan. And let's go ahead and select an existing, well, let's see, I actually have, maybe I already have a plan created. Let me just take a look here. I might already have a plan based on these projections. Let's take a quick look here. And we'll click on Add. Yeah, I do. I do have a plan. It's called Future High 5. Okay, we're going to open that up. Here's Future High 5. Okay, you'll notice down in the statistics window down here that the numbers I'm looking at here are from projection number 1, the projection I was just looking at, as well as the year 2005. Again, the base for these projections was the year 2001, but I'm looking at 2005. Let's actually look at 2001. There's our projection year. We'll pick that. Here's 2001 numbers. Okay, these are current numbers. Perhaps I wanted to open up an existing school out here to the east side of the district. Well, I'm going to come in here and go to school and add a new school, and I'll call this new site number 5. And I'll give it a capacity of, say, 1,950 kids. I now have new site number 5 out here, and let's change the color. It's yellow. It's too close to one of our other schools, so I'll give new site number 5 a slightly different color. We'll do a, I don't know, sort of an orangish color. Okay, so we've got new site number 5 has been added to my plan in the table of contents. It also, by default now, is the target school as I start my redistricting efforts. So now I'm just going to come in here and start assigning, and I'm going to grab a whole bunch of study areas out here to the east side of the district, taking away from some of my existing schools. These students, the number of students in this area in 2001, down here in my proposed statistics, is 843 students. Well, okay, that's really not enough to open up a school, but we'll go ahead and make that assignment anyway. And so we've created an attendance boundary out there on the east side of the district. Okay, that's nice and dandy. Let's see at some point where those numbers go in the future. Let's go ahead and stop my assignments and save that assignment. And we're going to go back up to our plan properties, and let's move out into the future with that boundary. That's 2001. Let's look at 2003. Well, we go from 840 something to 927. Okay, we're growing. Let's look at maybe 2007. Okay, woo, okay, there's some high growth in those next few years. We're up to 1,820 students. We're getting up to a point where obviously that makes sense for that high school. So the key here is I'm working with a plan now, not just existing students and doing demographic reporting and getting counts of kids. I'm actually getting counts of students by grade level, by planning area, by year, based upon projection number 1. Very powerful to help you model the opening and closing of schools and looking out into the future using these study areas and projected enrollment to try to plan for the district. Okay. Now, I might also say, since this particular redistricting plan is connected or using the numbers from projection 1, if I were to go to my projection and modify any of the variables in this projection number 1, the numbers will update, and when I refresh, it will actually update the numbers down in my redistricting plan because everything is linked together. Now, this is nice and dandy. I obviously have great tools here to plan future enrollment and look at my enrollment forecasts and so forth and print those out and print maps and whatnot. But sometimes I'd like to get other data too to sort of back up my ideas, and maybe the board might be interested in the socioeconomics of a particular area. So what I can do here is I'm going to actually select one of these attendance boundaries that I've designed and go out and grab third-party demographic data and do some other reports. So I'm going to come in here first of all and turn off a couple of layers here, and I'm going to bring this in, and I'm going to select, say, Villa Park High School's area. Okay. So I'm clicked on this particular polygon, and then I'm going to go up to what we call the Community Analyst. This is actually an Esri site. And I'm going to choose Redistricting Plan. And I'm going to do a Demographic and Income Profile report for that particular boundary that I just created. And I'll call this Villa Park Area Demographics. And click on Run, and it's going to generate and take that polygon, that area, send it up over the internet, and very quickly generate a report for me, give me population and other types of data. Here's my demographic and income report for Villa Park area demographics, showing this 2010 census data for a number of demographic and housing variables. Their 2011 most recent estimate, as well as a 5-year forecast for population, households, families, and so forth. Also, households by income, estimated numbers in 2011 and 2016 in percentage, per capita income, population by age group. So this is not just student population, this is overall population. So age 0 to 4, preschool, if you will, 2011, 2,423 kids in that high school attendance boundary, going up to 2,450, pretty much even, and percentages of population, race and ethnicity, as well as a number of charts and so forth. Okay, these reports can be saved locally, and I can generate a whole number of different types of reports. And these reports can be downloaded in either PDF or Excel. If you do them in Excel, obviously you can copy and paste the data into other reports that you might be creating as well. There's just a variety of reports, demographic and income profiles, tapestry segmentation to know what kind of people live in the area. Maybe you might want to, understanding the demographics and the type of people that live in the area, you might customize certain programs or whatever to different areas of the district as well. Information about, just a whole bunch of information, detailed age profile, so forth and so on. So there's a variety of data reports that you can get by taking these boundaries and quickly uploading them over the internet and getting third-party demographic reports. Okay. So hopefully this has been of interest. There's so much more we can show, and an hour really doesn't do justice to this. But at this particular point, I will see if we have some questions. And if you have any questions, feel free to type those in at this particular point. Looks like we've got a couple here that have come across. Well, I think I've covered this one. Again, let me just reiterate. The question is Esri software required for using SchoolSite? Well, when I first started opening this application and started displaying kids and color coding kids, those were all using Esri's basic GIS software. And that is certainly a requirement to use SchoolSite. SchoolSite is extensions to Esri software. Esri software is very generic in nature, allows you to do some really cool mapping and analysis, but it doesn't really give you the tools you need for school planning per se. And what we've done is we've added extensions, if you will. I'll show on the screen. We can go to extensions. And extensions basically are add-ons, if you will, to the software. Esri basically built these really great tools, but they're not specific to any one industry or any one particular function. And so SchoolSite are extensions or extra toolbars added in there that add extra functionality for school planning. So the answer is yes. In a short answer, yes, Esri software is required. We generally, when you license our tools, SchoolSite tools, we include licenses for Esri software as well. Let's see, we have another question. What's the best place to obtain street data? Well, again, most likely you're going to want to check with your local agencies, government agencies, your county. You'd be surprised how many counties, if you just call them up and talk about GIS, that, yeah, you can find data and so forth. A lot of times they have street data. Many times they have parcel data, and parcel data can be very powerful because it's very accurate information. You can do queries and say, well, we need to notify all the people within a certain distance of this particular school, all the property owners. Okay, let's get that information from the parcel data. Okay. Also, counties have voter information as well, so you can map voter registration information, not necessarily demographic planning, but what about bond election campaigns? Maybe on the side, people away from the district, people can be assisting and looking at voter data as well and targeting specific areas for voting efforts for bond elections and so forth. So check with your city or county first. If they do not, in the rare instance if they do not have data, then there are third-party data sources as well. All of the car navigation systems these days, TomTom, Garmin, all of those, Garmin uses Navtech data. TomTom data is also available. All of the car navigation system companies with their map data license their data for use with the Esri software because the Esri is just the standard out there. Okay, so there are commercial sources as well to get started. And we can chat more about that. If people are interested in learning more about how to go about get data, by all means, send us an email, give us a call. We'll be happy to chat with you about that. Another question here from Arizona. How much training is involved? Well, this really depends on what you're trying to do. If you are doing, you want ArcGIS, ArcView, and you have, say, just our redistricting tools, not forecasting, but you're just doing some redistricting. ArcGIS and redistricting, we typically will do about 3 days worth of training. That training includes just understanding the basic concepts of the software, how to work with layers, how to color code maps, how to get data and edit data and so forth. And once you understand the concepts of the software in roughly the first 2.5 days, the redistricting tools are very, very simple. I mean, you get comfortable with working with the software. It's just point and click to get out demographic reports and so forth. Okay, so roughly about 3 days if you're new to ArcGIS and to redistricting. If you're interested in the enrollment forecasting as well, which brings everything, of course, together, that's an additional roughly 2 days of training. So typically a full training session might be up to 5 days. Of course, with anything, does that make you an expert? We'll be honest with you, of course not. You're going to learn things as you go along, but it certainly gets you well started on the path to using these tools. And of course, we're there to help you along the way as well. Are there easy ways to share boundary plans on the web? Now, that's a very good question. You know what? that is exactly where things are going in the future. I will say right now that ESRI's plans for this is version 10 of their software, and 10.1 is in beta now from ESRI. It will be out probably in the next 2 to 3 months, and it will allow you to take the maps here that we're looking at and actually publish those up. Shove the data up to the servers, to ESRI servers, and actually publish these maps on the web in literally a few mouse clicks. And that's a very powerful concept. It allows you to take what you're doing internally as the expert, the demographics person, okay, the planner, and make this information, maybe make these boundary plans and other maps and things you want to display and make available to people, both internally in the district and out to the public. It makes that ability to put that information out to the web very, very powerful. We are actually doing some testing internally with ourselves to make a custom site where districts can directly publish their redistricting plans up to our servers, sort of a web-based type of an application where you can publish your plans up to our servers, get a URL, basically post that internally or out on your web page so that people can get a live web map within literally a few minutes of creating this plan. And we're going to be building some tools for public input, so markup. Oh, I have a problem with this area, and they can mark up the map and submit their comments and so forth to your boundary plans. That's the direction we're going, more interactivity with the public and the community with these maps and getting them out there. So yes, there are ways, and especially stay tuned in the next few months. There are going to be some really exciting developments in terms of being able to publish maps and publish these redistricting plans and so forth up to the web. Let's see here. I think that's pretty much the questions we have for now. So I think we've also taken about our hour. So I really appreciate everybody, your attendance this morning. If you would like more information, let me give you some contacts. You can contact our office. Ken Ward would be a good contact here. Ken Ward's phone number here, toll free, is 888-337-4471, extension 208. That's 888-337-4471, extension 208. You can also contact him by email. That's kward, Kward, at davisdemographics.com. kward at davisdemographics.com. You can also visit our website, which is www.davisdemographics.com, and you can explore our website and more about GIS and what we've done with it. So hopefully that's been of interest to you. Thank you very much, everybody, for attending, and have a good day. We look forward to hopefully seeing you on future webinars.